Hello guys, welcome back. In today's video, we'll be going through physics questions. This is the question. Okay, we are going to start with these from 2009 question paper 1. The first question says that all measurable features or properties of objects are called. The answer is physical quantities. They are called physical quantities. Then the second one, which of the following numbers has four significant figures? A, B, C, and D. So D has four significant figures. We count the number of significant figures after a point. After a point. Like from here we have this one, 0. Then we are going to start from here, 2. Then this 0, 0, 0. So these zeros are irrelevant because they are coming after a number which is greater than 0, 2. Like for this one, this isn't four significant figures, it's three significant figures because of this number after a point it's 0, so we cannot count this as 1. No, we are going to count from 2. Okay, then we go on question 3. The question states the motorist travels 320 kilometers at 80 kilometers per hour and then 320 kilometers at 100 kilometers per hour. What is the average speed of the motorist for the entire trip? So here we have two scenarios or two trips. The first trip, the motorist traveled 320 kilometers at 80 kilometers per hour. So the average speed of the motorist for the entire trip can be calculated using the formula for the average speed. Total distance traveled divided by total time taken. We divide by total time taken. First, we need to find out the hours for the first trip and the second trip. So you can use the formula for speed, which is equals to distance over time. Just make time the subject of the formula, then you can find the time for the first trip. So the first trip, it says that it was 320 divided by 80 distance. So we are dividing distance. It's speed. Sorry, it's distance over speed when you make this time the subject of the formula. So you are going to obtain 4 hours. For the first trip, it will be 4 hours. Then for the second trip, you do the same. So for the second trip, it's going to be 320. It's going to be 320 divided by 100. This time around, it's 100 kilometers per hour. 100. Then the answer, it will be 3.2 hours. Therefore, you are supposed to add these two, the hours from the first trip and the second trip, because you are about to calculate for the entire trip. So it will be 4 plus 3.2, which is equal to, this is equal to 7.2 hours. This is 7.2 hours. Then the total distance traveled is 320 plus 320 is equals to 320 plus 320 plus 320 is going to be 640 kilometers. 640 kilometers. So the average speed of the motorist for the entire trip is 640 divided by 7.2, our total time taken. This is what? 7.2. 7.2. Then the answer will be 88. 88.89. It's 88.89. So here it's going to be 0.89. But when you round it off into two significant figures, it's going to be 8 point, sorry, not 8.9, it's going to be 89 kilometers per hour. So the answer here is it's D. Oh, sorry, it's B. 89 kilometers per hour. Then the fourth one states that a stone of mass 400 grams is lowered into a measuring cylinder containing water. The water level rises from 300 centimeter cubic to 500 centimeter cubic. What is the density of the stone? What is the density of the stone? So the density of a stone can be calculated using the formula of density is equal to mass divided by volume. When the stone is lowered into the measuring cylinder, the water level rises from 300 to 500 centimeter cubic. So we can find the difference, as in we can subtract. We can say that 500 minus 300 is equal to 200 centimeter cubic. 200 centimeter cubic. So the mass of a stone is given by 400. The mass of a stone is given by 400. Then the density of a stone, it will be 400 divided by the difference, which is 200 centimeter cubic. 200 centimeter cubic. So the mass of a stone will be 2 grams. When you divide these two, it's going to be 2. So this will cancel, this will cancel. It's going to be 2 grams. 2 grams per centimeter cubic. Then our answer here is D. It's going to be D. Question 5. A force acts on a mass. A force acts on a mass of 1 kg, producing an acceleration of 1 meter per second squared. This force is called dash. We have tension, Newton, weight, and friction. So this force is called 1 Newton. 1 Newton is defined as the force needed to accelerate 1 kilogram of mass at the rate of 1 meter per second squared. In other words, we can say that 1 Newton, we can say that 1 Newton is equivalent to 1 kg. Sorry, here we have K. This is K. Equivalent to 1 kg times 1 meter per second squared. So the answer here is Newton for B. Time is not with us. This video is going to cut anytime soon. Okay, so we have this one. Question 6. A uniform plaque of length 10 cm is in equilibrium as shown in the figure below. A force of 100 Newton is applied at a point A in the direction given. What is the weight of the force? The weight of the force. Okay, let me try to connect on